In this recording, we're going to learn how to find the inverse of a function algebraically and graphically. So first we're going to start real simple. We'll start with a set of ordered pairs here, a relation, which happens to be a function, right? Because there's no x value that has two different y values, right? There's no element of the domain that's mapped to two different elements of the range. So to find an inverse, the key here is switch x and y. Maybe we just want to write that down right nice and big up in our side. Finding an inverse, switch x and y. That's the key idea when you're finding an inverse. Now, when you have a set of points like this, it's very simple. You're just going to take each one of these ordered pairs and switch their x and y around and use appropriate notation. So for that first one, it's simply going to look like this. You're going to write it as f with a -1 superscript. That's called inverse of f of x. And then just switch each one of those points x and y. All right, our next example is a linear function. And when we want to find its inverse, we're going to still switch x and y. But first off, we have to call this y instead of f of x. That'll be our first step in terms of finding the inverse. Remember, we did this earlier with our Celsius and Fahrenheit example. Now, we're going to switch x and y. So I'll change my color here. This is now the inverse. What I have in blue is not the inverse. It's just rewriting that original one with a different format. And you're very familiar with that. If I asked you to graph that function f of x on your calculator, you'd immediately go to the y equals, right? You understand that these are synonymous notation here. So now I've switched the x and y. Now I have to get y by itself. So like I could graph it. I mean, this is the inverse in red, but it's just not in a very handy form. So let's go ahead and add 5 to both sides. And now let's divide both sides by 3. So here's our inverse. Y equals x plus 5 over 3. But I'm not going to leave it in that format because if I do this next example and it has a different inverse, I won't really be able to tell the difference between these two y's because they don't have a name. All right, so let's relate this one specifically back to this original function called f of x. Let's write the answer this way. Inverse of f of x equals x plus 5 over 3. That's how we'll express our final answer. Okay? Next, this function is called g of x. So our final answer, our inverse, is going to have g with a -1 superscript. Okay, remember, I'm not saying g to the -1. That wouldn't be correct. That means something else if you have a variable raised to the -1 power. All right, so I'm going to switch x and y. Okay, haven't switched x and y yet. I'd like you to work this one out. Get as far as you can and then play the recording. So hopefully you paused, you worked this one out as far as you can. I have the equation written in y equals form. I'm going to switch x and y here. Now there's a couple ways we can solve this for, I just messed up when I wrote that as a double x. There's a couple ways we can solve this for y. Okay, we can certainly subtract 7 from both sides. I did this differently when I did the Celsius and Fahrenheit example. I think what I'm going to instruct you to do here is when you have an equation that's got a fraction in it, let's immediately multiply by the lowest common denominator that will divide out that fraction. So I'm going to come in here multiplying all the terms by an 8, the effect of which divides out that denominator. So now I just have a clean equation with no fractions. Let's call it 8x equals 3y plus 7. I know that's pretty easy for you to solve from here. Go ahead and work that one out if you haven't yet. So hopefully you finished that one out. This will look like 8x minus 7 is 3y. Now we're going to divide by 3 on both sides. And in so doing, I'll get 8x minus 7 all over 3. And I'm going to write this, I'm going to kind of skip a step here, not just write it as y equals, I'm going to write it as inverse of g of x. So say that out loud to yourself. Inverse of g of x. That's how we pronounce that when we see that notation. Okay, let's get some steps right here. Okay, so our steps, as we've done so, we rewrote in y equals form, if necessary. If it's already in y equals, no extra step there. Switch the x and y. Solve for y using all your inverse operations. You hear that word? Inverse operations. It's related. Finally, we're going to express it in appropriate notation. If it started out as y equals, you just express it this way. That's called the inverse of y. Or if it's f of x or g of x, you've got notation for that. Okay, so jot down those steps and proceed when you're ready. All right, finally we're going to talk about graphs. Graphs are actually pretty easy. You got a graph, switch x and y of all the points. Well, you can't do all the points, right? So pick as many integer points as you can on this grid. I've identified the point 0, 2. Try to find at least 4 other integer points. Excuse me, at least 3 other integer points and make a dot on them, just like I've got here, my blue dot right there, my point. So hopefully you've taken time to identify 1, 1, 4, 4, I'm sorry, 1, 3, 4, 4, and 10, 5. Excuse me, 9, 5. Those are our points. 1, 3, 4, 4, and 9, 5. So I'm going to switch x and y for each one of those points. I'll do those in red. So instead of having 0, 2, I have 2, 0. Remember doing this with our Celsius and Fahrenheit example. Now I have 3, 1. I'm taking that point's coordinates and switching its x and y. Now when you invert the point 4, 4, it's still 4, 4. Just like that point on our Celsius and Fahrenheit thermometer, negative 40 was the same as negative 40 in both temperature scales. And now 9, 5 becomes 5, 9. Okay, so then just do your best. It's gonna, this is like a radical graph. This is like the top half of a parabola. So this is gonna be like the right half of a parabola, okay? Okay, and then I'm just gonna put a little arrowhead on there. And now we have to label them. It says label. So this one was called g of x. So this one is called inverse of g of x, right? And finally, it says draw and label the axis of the line of symmetry. So I'm going to ask you to pause in a moment and think about what is the fold line. I can't do this very well with this screen, but on your paper, what is the fold line? So take a moment to try to fold your graph so that this and this go right on top of each other. That point maps to that one, that's on itself, and so you have a fold line. So hopefully you came up with a fold line here. Grab a little dotted line. We're going to make a dotted line that goes through the origin. It's the line y equals x. That will always be the line of symmetry for an inverse, a graph and its inverse. The line of symmetry, y equals x, right there, okay? So label that and draw it in with a dotted line. Let's list some steps out. Okay, so what we did was we switched x and y for not all points, but the convenient ones, right? You only need several points in order to make a curve. Make the curve or line, whatever's appropriate. Label the graph of the inverse as well as its original, and then draw in the line of symmetry. Use a dashed line style for y equals x. All right, let's finish out this way. I want you to complete the table for this graph. Identify the domain and the range of g, and the domain and the range of the inverse of g. Keep in mind, the way to find the domain is you move from left to right until you hit the first point, and then you say, well, what's the last point? I'm going to go ahead and put arrowheads on this just so it's really clear this function does continue. Okay, so pause, play the recording, we've got some answers here. Okay, so hopefully you came up with something like this. The domain of g of x is 0 to infinity, and its range is -2 to infinity. The domain of the red graph is +2 to infinity, and its range is from 0 to infinity. Notice how these are switched. No coincidence, because we're switching x and y. Thanks for watching.